Sadence, and my science fair experiment was, my question was, how do different types of sugars affect the caramelization process? Mainly focusing on swerve. Well, my hypothesis was that swerve would burn at the caramelizing stage because if you look on the package, the baking temperatures are really, really low. The highest baking temperature for swerve is 250 degrees. But the caramelizing stage reaches 350 degrees Fahrenheit, which is 100 more degrees than the baking temperature, so I thought it was personally going to burn and not caramelize. I tested my experiment by actually trying to so we took a pot and we put a cup of sugar in the pot and then a fourth of a stick of butter and then a 1/8 cup of water, and then at different temperatures we'd take a spoonful and place it on the parchment paper, which you can see here in this middle photo. At each stage we took a spoonful, and then we also used 2 different thermometers because the thermal gun was actually not taking the internal temp, which is what we mainly needed. It was taking the surface temp, which we didn't really need that temp, we needed the internal temp. So we also used a candy thermometer to get better results. So, my different types of sugar were my granulated sugar, which is your white sugar, which is your controlled variable. And then you have the swerve, which is also named erythritol, which is a plant sugar. And then you have powder sugar, which is basically white sugar, just grinded up even finer than sugar itself. Okay, so my different stages had different, very, very different looks to them. So on the granulated or controlled sugar, it was actually pretty light till it got to the caramel stage. What the caramel stage is 350 degrees Fahrenheit, which is the caramel stage, or the brittle stage, which is what they also call it. And then you have your swerve, which also didn't get dark till the very, very end stage, which is 350 degrees Fahrenheit. But with the swerve, it was very hard, but when you try and crack it, it was hard. But as soon as it hit liquid, it dissolved really quickly. And then you have your powdered sugar, which actually didn't harden at all. So it stayed in a caramely, taffy kind of stage and syrupy. Well, the first 2 of the powdered sugar actually didn't harden at all, and it was just like soup. And then your second 2 were more of a syrup consistency, and then your last one was a poly taffy kind of consistency. But they all did caramelize at the same stage. They also had very, very different smells and texture. Their textures, so the swerve actually didn't combine all the way, and the sugar and the butter were pulling apart, and that's why we think it was very grainy. So my hypothesis was not supported because I thought it was going to burn at 350 degrees, which it did not. It actually caramelized very, very good, and it actually was a lot harder than the sugar itself and the powdered sugar, but it also dissolved a lot quicker. Also, at 350 degrees Fahrenheit, we had to do the swerve. We had to do all of them twice because the first one got a little messed up on the swerve, so we just wanted to make sure all the experiments were equal. I thought why this would be important to learn or know how to do is because people that are diabetic or on keto or on many different diets where they cannot have sugar, this would be a good alternative for them because it tastes almost exactly like sugar itself, but more of a nutty fruit and plant-based sugar. So if I were to do this project again and change something, I would change the amounts. I'd half them again because the full amounts were a lot, so we halved that, and it still was a lot of caramel in the end, so I'd half that, so I wouldn't have as much left over.